Hi everyone, we are going to have the concept of inequality today. Gladly, not about world inequalities, but something much easier to solve, triangle inequality. We will focus on the inequality among the sides of a triangle, as well as the relationship between its angles and its sides. We know that triangles can be classified according to side measures. We know that a triangle which has three congruent sides is called an equilateral triangle. A triangle which has at least two congruent sides is called an isosceles triangle. And a triangle with no congruent sides is called a scalene triangle. We also learned that triangles can be classified according to angle measures. A triangle with one right angle is aptly called a right triangle, one with an obtuse angle is called an obtuse triangle, and one with all acute angles is called an acute triangle. But does it mean that as long as we have three random segments, we can automatically form a triangle out of them as sides? Well, that isn't the case. We are governed by the triangle inequality theorem. This theorem states that any side of the triangle must be smaller than the sum of its two other sides. So, in this triangle, if we take the sum of A and B, C is smaller than it. Similarly, A is also smaller than the sum of B and C. And lastly, B is smaller than the sum of A and C. Notice that we can actually combine the first two inequalities. The first inequality states that A plus B is greater than C. The second says that B plus C is greater than A. Now we know that manipulating the second inequality algebraically, C becomes greater than A minus B. Thus, combining these into a single expression, C is smaller than the sum of A and B, but greater than the difference of A and B. In other words, any side of a triangle is bigger than the difference of the measures of the two other sides, but smaller than the difference of their measures. We can illustrate this using this triangle here with its measures. Let us take side A, which measures 3.1 units. By the triangle inequality theorem, A is greater than the difference of B and C, which is 3.95 minus 3.67, but smaller than the sum of B and C, which is 3.95 plus 3.67. Or that is 3.1 is greater than 0.28 but less than 7.62. Using the same logic for sides B and C, for side B, 3.95 is greater than the difference of A and C, which is 0.57, but it is smaller than the sum of A and C, which is 6.77. For side C, 3.67 is greater than the difference of A and B, which is 0.85, but it is smaller than the sum of A and B, which is 7.05. We can apply the triangle inequality theorem to solve some problems. Let us say we have this. The sides of a triangle are x, 15, and 8. What is the range of possible values of x? To solve this, we remember that the triangle inequality theorem states that x must be greater than the difference of the other two sides, but smaller than their sum. So, x is greater than 15 minus 8, but less than 15 plus 8. Simplified, we get the possible range of values for x, which is x is greater than 7, but less than 23. Now we are also going to investigate the relationship between the angle and side measures of a triangle. In exploring the side angle relationships, we want to look at triangle ABC. Which angle is the largest here? It is angle A, which measures 84.77 degrees. This angle is opposite which side? It's opposite the longest side, which is BC, measuring 5.31. Now, let's take a look at the smallest angle, angle C, which measures 42.46 degrees. It is also opposite the shortest side, which is AB, which measures 3.6 units. This actually illustrates the side angle relationships in a triangle. where the largest angle is opposite the longest side and the smallest angle is opposite the shortest side. So if we order the angles from the biggest to the smallest, we will have angle A, angle B, and then angle C. And following the logic of the side-angle relationships, we can also arrange the sides according to size from longest to shortest. So we have BC, AC, and AB. Now let us have a sample problem. The angles of a triangle, when arranged from smallest to biggest, are as follows. Angle G, angle E, and angle O. Arrange the sides from shortest to longest. Now, to solve this problem, we remember the side-angle relationship, which states that the largest angle is opposite the longest side, and the smallest angle is opposite the shortest side. Thus, we first take the shortest side, the side opposite angle G, which is EO, followed by the side opposite angle E, which is GO, and lastly, the side opposite angle O, which is side EG. Now we have solved the problem. Pretty easy, isn't it? So that also ends our lesson on triangle inequality.